obviously I'm a little bit behind right now, so tonight's homework is, it's assignment number 75. Specifically, it's problems 2, 3, 5, and 7. Alright, and you guys know I'm not able to stay for tutorials today, and I apologize for that. I really wanted to, but I need to leave here, go to North Side, go to North Forest. So that's not going to happen. I hope last night's take-home quiz went well. I mean, this was like very skills-based. Do you have all the right skills? Like, very likely there will be no curve on this at all. This should be like a straight 100 for, I mean, most people not named David. I think are gonna, all right. All right. So let's get rock and rolling. Stephen, are we ready?
Yes.
All right. All right. So the quizzes are in the middle of the table. Carmen, if you wouldn't mind going around and picking those up, I'd appreciate that. And today, I think is going to be a very good day for everybody in the room. All 11 of you have either, let me get this right, have already taken AP Physics or are taking AP Physics. No? Who's not in AP Physics?
I wouldn't count my experience as actually taking it.
Okay. Lewis, David, Polybone, and Aaron. Okay, so the 4 of you, no AP Physics experience, past or present.
Yes, you do.
Oh, but you're just good at physics, as you are good with all things. Very confident young man that you are. All right. All right, so I know we've talked about this before. You are not just enrolled in an AP Calculus class. Shut up. You are also enrolled kind of in a physics course. There's some physics that intersects with calculus that you already know, that we've already talked about. What are some of the physics concepts in calculus that we've talked about? Derivative, but specifically in the world of physics, like we started with this idea that the derivative means slope of the tangent line, right? Yeah. And like Newton had all these ideas, and then eventually we figured out we could actually apply the derivative in the physics world. How? Specifically, how? What are those physics connections that you guys remember? Colin, give me something.
The absolute value of speed equals displacement.
What?
So no. So many no's. So many no's there. You lost me at absolute value. Lewis, help me out here.
So we talked about how speed, the derivative of speed is acceleration.
Oh God, we never said those words either. Never have I said that the derivative of speed is acceleration. Never have I said whatever the words are that you said. We had some conversation, I swear I was there, I've got footage to prove it, is that if you start with position and you take a derivative, where do you get to? You take one derivative, one little derivative, and you're going to get to velocity. And if you take another derivative, you get to acceleration. We may even have had a conversation, and this would be something to talk to Mr. T about. If you take another derivative of acceleration, you get to something called jerk. And I don't mean that in like a mean, hateful, like I think you're a jerk way. I mean like it is a thing. It's a thing. So for like position, we normally have units of something like meters, or maybe it's feet, maybe it's yards. When we get to velocity, the units down here,
Meters per second.
maybe it's like meters per second, maybe it's kilometers per hour, all sorts of things like that. When I get to the world of acceleration,
Meters per second squared.
meters per second, or meters per second squared. If we were going to talk about jerk,
Meters per second cubed.
it's meters per second cubed. You really don't need to know about jerk, but it is popular. The physicists have extended our derivative concept down a little bit further. Now, when we started having conversations about speed, and there is something that you're all supposed to know about speed and its relationship to velocity. Adelaide, do you remember the relationship between speed and velocity? No? Somebody help her out. Things you remember. Speed and velocity. What's the connection there, Carmen?
Speed is the absolute value of velocity.
Okay, speed is the absolute value of the velocity. Okay, true. Now in calculus, in calculus-based physics, I'm going to ask you questions. I'm not going to say, what is the speed? I'm going to ask you questions about is speed increasing or decreasing. How do you decide? Using your knowledge of calculus, how do you decide if speed is increasing or decreasing? I'll give you a hint. There are two things that you look at. You need to look at two things. When you have a conversation with somebody near you, what are the two things that you look at to decide what speed is increasing?
Oh yeah, you look at it but I don't know if they're changing the same direction. If they're changing in opposite direction, how do you know when speed is increasing? It's speeding up, right? They're changing it.
If speed is increasing, the two things that you have to look at, velocity and acceleration. But specifically what you're looking at, if speed is increasing, what we need to know is that there's something true about the velocity and the acceleration. The thing that's true about the velocity and acceleration, it's not that they're both increasing or decreasing. They have the same sign. So V of t and A of t have the same sign. And considering how few folks were able to tell me that, I hope we're getting all this written down. Speed is increasing when velocity and acceleration have the same sign. If velocity and acceleration have different signs, then speed must be decreasing. This is pretty much all the physics that we've talked about in calculus so far. Quite honestly, that's like 75% of the physics that you need to know. All right, what I want to do is I want to give you guys a minute or two to read through this opening problem. We're not going to do the old stuff. We're just going to focus on the new stuff. But read through this problem. We're on page 33 in the student handout. And be ready to talk about what's going on. And maybe someday when I revise this handout, new pictures will get put in, and maybe it'll be some of your faces up there at the top. Give me 1 second.
Yes.
Yep. We haven't learned that yet.
Oh,
That's where we're
area
going.
is
All right, so we've got two young thugs who have decided to take my car for a ride. Please don't do that. It also doesn't get above 60 miles an hour without shaking anymore. So don't do that. No, don't fix that. All right, so assuming the car starts in the parking lot at Southeast Campus, the boys drive to Crenshaw Road, graph their velocity is shown, blah, blah, blah. V of t greater than 0 represents car traveling west on South Shaver Road. Okay, part A, I just want to talk through like these first couple of pieces. What would you do? I'm not even interested in the answer. If this was an A-B class, I would give you guys some time to work on these pieces. I just want to have some quick conversation. So if I wanted to determine the acceleration when the boys have been driving for 4 minutes, what would you do?
The slope.
Aaron, what would you do?
Well, I would first more label that it's a VT graph.
Okay,
So
right.
the
We've got
acceleration-
time versus velocity.
The acceleration would be the slope. of the
Acceleration is the slope because acceleration is derivative of the velocity. So at time t equals 4, if I want to find the acceleration, find the slope, everybody going to be okay?
Mhm.
All right, good. You're frozen for a little bit. B, identify all the intervals where the speed of the car is increasing. Looking at the graph, where does the speed have to be increasing? How would you make this decision? Myra, what would you do?
Make sure the acceleration and velocity are the same sign.
Okay, we need acceleration and velocity to have the same sign, right? So for example, on this first interval, what do we know about the velocity? The velocity is positive because we're above the x-axis. Is acceleration positive or negative?
Positive.
Positive because velocity is increasing, so this is the place where it would count. Does anybody see another interval where the speed has to be increasing? I really want to focus on the friends that are not in AP Physics. Lewis, where else?
4 to 5.
From 4 to 5. From 4 to 5, you're 100% right. Convince me that the speed is increasing here.
So the velocity is negative,
Velocity is negative, we're below the x-axis.
and the acceleration is negative.
The acceleration is negative because the velocity graph is decreasing. David, do you see any other places where the speed would have to be increasing? Between 7 and 8, why? Velocity is positive and the velocity is increasing, so acceleration is positive. Giselle, we're good? Alright, good. Part C, assuming that at time t equals 3, the position is given by x of 3 equals 4, write an equation for the tangent line at t equals 3. Have a quick conversation with somebody near you. What would you do? The position at time 3 is equal to 4. I want the equation of the tangent line.
Oh, wait.
Okay. Alright, we know the position at time 3 is equal to 4. I want the equation of a tangent line. Just about everybody seems to be doing this. Stephen, what are all the friends doing if they're going to come up with the equation of a tangent line?
L of x equals 2 parentheses x minus 3 parentheses plus 1.
Okay, what I just heard Stephen say was L of x is going to be 2 times x minus 3 plus 4. Where'd the 2 come from?
The velocity graph.
Okay, we're going to look at the velocity graph, and we would need to know what's the velocity at time 3, because the velocity at time 3 is the derivative of position. Okay? Alright, let's see if we can get this part right. Using the tangent line equation at t equals 3, estimate the position of the car at time t equals 3.3. That should be the easy part of the question. David, can you put those right? Okay, if you're going to estimate the position at time 3.3, we're just going to plug in. What I'm really interested in, though, is will that estimate be an overestimate or an underestimate, and why? Talk to the folks around you. How do you know for sure? At 3.3, is that going to give you an overestimate or an underestimate, and how do you make the decision? So position at 3.3 is going to be approximately whatever we get by plugging in 3.3. How many guys are going to go for an overestimate here? Okay, how many are going to go for an underestimate? How many have no idea how to make this decision, be honest? Okay, thank you for the honesty. The decision about overestimates and underestimates is always a conversation about concavity. If you knew the original position function was concave down, what would you know about the estimate? Uh-oh. If the original graph was concave down, think about your tangent lines. If your graph is concave down, then those tangent lines have to be above the curve, so it has to be an overestimate. If you had a graph that was concave up, then the tangent lines are going to be below the graph, and then you're going to have an underestimate. Everybody okay? Okay. So, what kind of estimate? To answer the question about position and the concavity of position, you're going to have to look at your velocity graph, because this is the only thing that you've got. And if I look from x equals 3 to x equals 3.3, the thing that we know about the velocity graph that gets you into the concavity conversation, the velocity graph is decreasing, so your position function is concave down. And if the position function is concave down, then the tangent line has to be, okay? It wouldn't be a bad idea to write that down. Okay? You've got to tell me about the interval. So on the interval 3 to 3.3, right, on the interval 3 to 3.3, you know that the velocity graph is decreasing, which means that the position is concave down. Tangent lines are above, so it has to be an overestimate. Steven?
Will it work if you just plug in like 3.3 and see that it's actually a larger number if you plug in 3?
But here's the thing though, you're not comparing what's the position at 3.3 to what's the position at 3. You're comparing your estimate of the position, like your best guess for the position at 3.3 to what the true answer would be at 3.3. And you don't know what the true answer is at 3.3, you don't have enough information. Does that make sense? Alright, so here comes the new stuff, and I think you guys are going to be just fine. Here's where I want to spend the last 15 minutes. Okay, last 15 minutes, same graph. It's time to put your definition of a definite integral into some context. Just like derivative had a calculus meaning, but it also has a physics meaning, so does the definite integral. So for all the friends watching at home, if I were to ask you guys what that means, not what is it, what the number is, what does it mean? Have a quick conversation with somebody near you. What does that mean? What would you tell them?
What?
I love having a small enough class so I can stand in one spot and hear all the conversations. Everybody should have small classes. That would be nice. So the notation obviously means definite integral. Definite integral of f of x with respect to x from a to b. But the meaning is area bounded by 4 things. By the x-axis, the function, the vertical lines x equals a and x equals b. Okay? So in this case, find the value of the definite integral from 0 to 5 of v of t dt. You get, like, finding the area, hopefully it's an easy thing. Right? I gave you like a really nice graph. What would it mean if you found that definite integral from 0 to 5? If you figured out what all this is over here, you have to, like, this is going to be the thing where, like, it's a physics concept now. Lewis knows what it is. Myerson seems to know what it is. What I'm asking you to find is the area bounded by the velocity graph and the x-axis from 0 to 5. Lewis, what does this have to mean?
The position of the
Whoa.
I can't 100% agree with you. It is so darn close, and all the AP physics students know exactly where the mistake is.
0.
It's not position.
Displacement.
It's displacement. Displacement is a measure in change in your position. Okay, and so all I need you guys to do, see what you can do with part F, see what you can do with part G. Units are going to be important here. We're going to get to position. 100% going to get to position. Oh yeah, we are definitely going to get to position. Alright, so I want to find the value of the integral from 0 to 5. Here's my velocity graph. Options for finding that area. Okay, trapezoids. I love the fact that some people are actually using the word trapezoid now. Okay? You could also say, what, like triangle, rectangle, triangle, triangle? But if I really want to be efficient, if I want to get there as quickly as I can, I think trapezoid would be better. And so if I have a trapezoid, then there's a base there, there's a base there, there's my height. Okay? So your integral from 0 to 5 b of t dt is going to be 1/2. That first base has a length of 4. That second base has a length of 1. And you've got a height of 2. This area over here, I've got a triangle, so it's 1/2 times my base is 1 times my height is 2. And the thing you want to make sure that you don't get wrong, it has to be negative. David, why does this have to be negative? You're below the x-axis, so whatever this is, this has to represent a negative area. And then from here, was that 5? Is that 5 minus 1? So I think we have 4. 4. And the units? Yeah, the units, if you think about the units here, on the x-axis you're being measured in minutes. On the y-axis you're being measured in kilometers per minute. When you're doing an area computation, you're doing lengths times height. Minutes times kilometers per minute has to be kilometers. In terms of the meaning, what I need to see is, we'd say it's the displacement. It's the displacement. Tell me what you're measured in. Measured in minutes. And I need a time interval. If all you ever tell me is displacement, that's not going to be good enough, because displacement, I need a starting point and I need an ending point. So it's the displacement measured in minutes from, what is this, t equals 0 to t equals 5. Everybody good? All right, G, when the boys have been traveling for 6 minutes, what's the total distance that they have been traveling? I'll let you guys play around with that for a little bit.
Then you add, so
Wait, what was it?
7.
2.
I did it by the big
Wait,
triangle.
is it displacement? Oh, you know,
No,
it's
what's
7,
this?
right?
This?
No, this is
I did it.
That's what I said.
Oh, just make it positive. You just make it positive.
And you add the
You said 6.
Still was wrong.
7.
Because y'all said 3.
displacement.
Okay, so what's that?
Yeah.
I agree with you, it's 7.
I corrected you. You said 4.
You want total distance traveled. And with total distance traveled, this negative area counts as positive area. Okay. All right. All right, from walking around, and I realize we've got the deck stacked here in my favor because everybody's got a strong physics background. We've at least taken physics. Total distance traveled is the phrase that pays. As soon as you see total distance traveled, like we knew already that this area over here was 5, right? And we can figure out that the area over here, 2 times 2, cut that in half is 2. The question though is, do we add them together or do we subtract them from each other? Add them. Why? Aaron, why are you going to add these together?
Because with no total distance, everything is absolutely right.
When you're dealing with total distance, everything it gets treated with an absolute value. Everything counts as positive. But think about what's happening like in the car. Andrew and I are in the car. We're driving on South Shaver Road. We're heading, in this first example, we're heading west. How far did we go? You went 5 kilometers in this first 4 minutes, right? So I know that part. Now what happens between 4 and 6? I've actually turned around, right? I've gone west, but at this point I'm turning around, I'm coming back to the school. With total distance traveled, you want to think about like the odometer on the car, right? You've traveled 5 kilometers, and then you're traveling another 2 kilometers. So in this case, total distance traveled is going to be 5 kilometers plus that 2 kilometers to be 7 kilometers. Everybody okay? When it comes to total distance traveled, area below the graph counts as positive area. Okay, so we should do the next one. I'm really interested to see if we can make it to I. So I want the values of those two definite integrals, and I want an explanation on what each one of these things is going to mean.
So this one is distance.
What happens when 6 is
If Andrew and I are in the car, maybe we're at a
Or
stoplight.
turn off the car.
Or we've turned off the car. Maybe we're in line at the Sonic. Maybe we're talking to the ladies on the side of the road.
Yeah, because you take
Don't talk to the ladies on the side of the road. They're there for a different reason.
You're trying to get home?
No.
That's exactly it.
They are on the grass.
Integral from 0 to 8, integral of the absolute value of v of t from 0 to 8.
Reaching no starting.
It's only that's
With
actually.
this
It's
one?
You never know.
I know.
Looks like there's
You never know.
I used to work by it. I know.
It would be double
That I.
C.
So this one is 4.5.
Oh.
So integral from 0 to 8 v of t
Yeah.
dt. Plus,
Thank you.
we know that's 5, we know that's 2.
And given 7.5.
Is that 1/2 over there?
Yes.
Alright, so the integral from 0 to 8 should be 5 minus 2 plus 1/2. Is that 3.5?
Yes.
Okay. So 3.5 kilometers, the integral from 0 to 8, the absolute value of v of t dt is going to be 5 plus 2 plus 0.5, 7.5 kilometers. And Andrew's doing the pity clap for Lewis, so you guys get this right? All right, the first one represents what? Okay, this be specific. It's the displacement. I need more.
From.
Measured.
What are we measuring in?
Oh, measured in minutes.
Minute.
No, what are we measuring displacement in? Displacement is a distance measured in kilometers from where to where?
But last time you said minute.
From t equals 0 to t equals 8.
That's not.
Yeah.
I didn't write minutes last time, did I?
He said
Oh, you
displacement
did,
measured in
yeah,
minutes
you
from
did.
T.
No, I didn't.
Yeah.
It's all film.
And
It won't be when I'm done with that film. Okay, displacement measured in kilometers.
He's gonna interject like I got another thought. He's like.
All right, and then this last one, if I take the integral of the absolute value of velocity, you guys have a better word for absolute value of velocity? Speed. So the integral of the speed function is going to give you total distance traveled. Total distance traveled, tell me what you're measured in.
Can you just say distance or is it total distance?
What are we measured in? Total distance traveled. Also measured in kilometers. And then this is going to be from t equals 0 to t equals 8 minutes. Lewis, what was your question?
Does that have to be total distance or can it be just distance?
You can get away with total distance. If you don't want to say total distance traveled, you can say total distance, and that's going to be okay. And all the friends are okay?
So you still have to say
All right, I'm really interested to see what your smarticle particles can do with part I. We'll talk in a little bit.
Only thing is that I was
What's the question? Oh, okay, so you guys are on part I. At what time are the boys?
Yeah, because he's saying even though
They're slowing down. They're still technically that traveling.
At 4.
they don't actually start in person.
Like not reversing, like switching direction.
No, they actually do switch directions.
That's what I'm saying. They switch direction. They switch direction at here.
He said reversing. I said switch direction.
Okay, right, so they like, from 0 to
4
4,
is
they're
fine.
going west.
Yeah.
What happens at time 4? They come back east, they're getting closer to the school.
Because that's when they stop. They stop.
Basically, the negative means getting closer again.
Yeah.
You know, say,
Yeah. So the change from positive to negative.
this is when you're changing. That's what you used to call it. You used to call it right here. The graph.
So when do you guys think they are part of the
For the change in displacement.
At T equals 4? Now do you have any proof?
Yes. That's 5 and then everything else goes. Yep, very simple.
Yeah, this was like
Yeah.
the first 2 months.
Lewis has convinced no one. All right, and what do you guys think? 4. Okay, all 3 groups have locked in the same answer. All 3 groups are convinced you are farthest away from the school at time t equals 4. Nobody has anything on their paper that actually would convince me or any of the graders. So here's what the proof is going to have to look like. So first of all, we're only interested on this time interval 0 to 8, right? I want to know when you are farthest away. I'm hoping you're having flashbacks to the last unit. If you are farthest away, another way to say that is when is... It's an absolute maximum question. So if we're looking for farthest distance, what you need to do is think about absolute max. What you want an absolute maximum of is you want the absolute maximum of your displacement. So like when would this expression here be greatest? This is what I'm trying to maximize. If we think about all those optimization problems that we did before, where are the places that you would actually check? When we do optimization problems, you check endpoints.
And wherever the graph crosses.
Okay, you check endpoints, so the endpoints here are going to be at 0 and 8. And there's another place that you check. It's not just endpoints. You check candidates, like internal candidates. Where's the candidate? Where might I actually have been farthest away?
At T equals 4.
At t equals 4, because what happens at t equals 4, my velocity changes from positive to negative. I stop going forward, I start coming backwards. And so my candidate is going to be at x equals 4 or t equals 4. The way we're going to start organizing this work, we're going to say, all right, so here are like my t values at 0, at 4, and at 8. And what's the integral from 0 to t of v of t dt? I've got some notation challenges here that I wish I hadn't chosen to do. At time 0, what's the value?
0.
Don't overthink this. At time 0, how far are you?
0.
0. At time 4, what's your displacement?
5.
5. And at time 8, what's your displacement?
3.
It's 3.5. So when are you farthest away?
4.
At t equals 4.
I mean, like, you know.
So displacement is greatest. Nice. Nice job, guys. That is definitely not the speed I would go at in an AB class, but we're going to continue playing with this tomorrow. What's the homework? It's assignment 75, problems 2, 3, 5, and 7. And Carmen and Celeste, the 2 of you are going to be absent. Mañana? All right, I will send you guys an email later today.